Hello guys, welcome back again. This is Networking Academy. So now we're we're going to answer the activity in chapter 5 because we have already answered the activities from 1 to 4 from 1 to 4 chapters. So we're going in chapter 5, the internet. So we have here the first activity. So this is called the Mac and LLC sublayers. So these two are type of sublayers. The instruction says, descriptions of the Mac and LLC sublayers are provided in the table. Click in the Mac or LLC fields to match the descriptions to the correct sublayer. So we're just going to match this statements to these two choices. We're gonna put some mark there. So controls the network interface card to the software drivers. So the Mac is dependent in hardware, and well, the LLC is dependent on the software. So there's a word here that the network interface card through software drivers. So it's software, so it is LLC. It works with the upper layers to manipulate information for delivery of data to higher level protocols. And this is the LLC because it serves for the management of the layers. Works with hardware support to bandwidth requirements and check errors if the bits sent and received. So it is the Mac. Allows access to the media signal and physical means standards requirements. So physical media standards requirements, which means that it also involves the use of hardware devices. Mac supports Ethernet technology by using CSMA-CD or CSMA-CA. Remains independent of physical equipment. So this is not the Mac because the Mac is dependent to physical equipment, which is the hardware. So the one dependent of physical equipment is the LLC. Checking that out. It's good. Notify internet frame field names. So we're going to drag these field names to their corresponding descriptions. So we use this pad to increase this frame field to at least 64 bytes. It's the header. Stripes in higher layer protocol has been used. So in chapter 4 I have mentioned that the type determines the protocol used. Frames are generating NIC or interface MAC address, source address. Because the main destination of the transmission. Assist a host in determining if the frame received is addressed to it. So it's the destination address because you're still determining the destination of the frame. Notifies destination to get ready for a new frame. Synchronize sending and receiving devices for frame delivery. Detects errors in internet frame. Synchronizes sending and receiving devices for frame delivery. So it is frame check sequence because it it checks the where the frame has been sent or delivered or received by the destination, and start of frame delimiter detects errors in an Ethernet frame, so it delimits the some of the frame flaws like that. So here we have identify Ethernet frame field name. So where IEEE 802.3 Ethernet frame fields, we're going to drag this seven terms here. So whether it matches with the byte here. So the I have read the frame fields, so there's a they have their positionings. So the first one is the preamble. Next is the start of the frame delimiter. Next is destination address. Next is the source address. Length. So this has been mentioned in the Ethernet frame topic. So it is told that it has the each byte representing one. Got it correct. So this activity, this switch it, I have already answered that. So you better check in the description below for the link in the video. So I'm not going to answer this because I have already explained it in my past video. So we're here at the activity frame forwarding methods. So the instruction says descriptions of switch frame forwarding methods are provided in the table. Click in the store and forward or cut through fields to match the methods to the descriptions. So we're going to match this again here, the statements. So we're gonna try this out. It works for me. So we have store forward and cut through forwarding method. So number one is buffers frames and the full frame has been received by the switch. Buffers frames until the full frame has been received. Yeah, I think it's the storing forward. Because what I know about the storing forward is it checks whether there is a like an error, which is the cyclic redundancy check, CRC. So I'm not sure about the acronym. Forgot. Checks the frame for errors before releasing it out of its switch ports. In if the full frame was not received, the switch discards it. Oh, it's stored forward. What is the cat true? Am I no error checking our frames is performed by the switch before releasing the frame? So it is the cat true because it doesn't have any error checking. Store forward is the one that has the error checking. Create method to conserve bandwidth on your network. Hmm, is the store forward somehow a safest way on in-frame forwarding? Destination network interface can discard any incomplete frames using this frame forward. So this is store forward. Yes, because it checks the flow within the forwarding of the frame. Faster switching method but they produce more errors in data integrity, therefore more bandwidth. Maybe you should let's try that true. Check. Oh my, finally. So I've got it wrong, these two. Hmm. Cut through. Okay, I'm kinda confused with this. Yeah, we still have number two. Oh no. So here we have the frame forwarding methods again. Still? Oh no, okay. Switch forwarding methods and the frame forwarding methods. The scenario based on the topology shown. Identify how the frames will be processed by dragging your ancestor power fields in the table. Hmm. So here we have this representation here. So this is our guide. So S1 is a brand new switch. PC1 is sending data to PC2. S1 is using full duplex MDIX and fast forward as a frame switching method. So here we have these statements here, and we're gonna fill these blanks by dragging them into their correct positions. Cabling used in this topology will be, oh, I think unicast, broadcast. Let's try this. Gonna check that. Okay, we got this correct straight through because I think it's the type of cabling. Oh no, okay. To find where PC2 is located, PC1 send out A. Oh, I think it's a unicast. Let's try to check that. Oh, cut through. Still incorrect. Turn forward. Broadcast. It's okay. So to find where PC2 is located, PC1 will send out a broadcast data frame. So it will send to both the PC2 and PC3, and then gets the feedback whether each of the end device has the proper location. PC2 will respond to PC1 based on the Mac a unicast. Okay. So in number two, PC1 sends out a broadcast. So it sends both to these two ports, and then this if this one is kinda is not the proper location that this PC was finding, So this one will send some unicast onto the first PC. If PC2 receives only half of the data in the frame, it will discard. Okay. Oh yeah, it will discard it because it will not process into going to other devices. Visitor receives many damage frames on port 3. S1 will likely change Mach 2. Starting forward. Am I correct? Okay. So if visitor receive many damage frames, yeah, it will go to error checking for fixing of the for the fixing of the transmission. Okay. Your signal is getting bad. It's kinda low. It's like oh, it's like a turtle. Okay. So do we still have any in this? Yeah. So we're done with this chapter 5. So you better stay tuned for chapter 6. And that's it for my chapter 5 activities. And don't forget to leave a like and watch my other videos also about this switch it the switch it the switch it activity, which I have answered in my recent video. So better check that out in the description below, and thank you for watching, and goodbye again.